Welcome back, friends. In my previous videos, we discussed about the non-polar covalent bonds, and in this video, we are going to discuss about the polar covalent bonds. So, as I told you in my previous video, that the non-polar covalent bonds, they are formed by the sharing of electrons between two atoms having the same electronegativity. So here in the polar covalent bonds, they are formed by the sharing of electrons between two atoms having different electronegativities. So polar covalent bond is the type of covalent bond in which the bond electrons are not shared equally. And this occurs because the difference in electronegativity of the atoms. So in the polar covalent bond, the electrons are attracted more towards the most electronegative element. The bond electrons are attracted more towards the more electronegative atoms, causing it to have partial negative charge, while a less electronegative atom become partial positive charge. So saying maybe we have a bond between hydrogen and chlorine atom. So we have hydrogen chloride. So in this hydrogen chloride, we'll have hydrogen and then chlorine. So from here, the electronegativity of chlorine is greater than the electronegativity of hydrogen. So the electrons will be pulled towards chlorine. This chlorine will pull electrons towards itself. And because chlorine will pull electrons, the shared electrons will be pulled more towards chlorine. It will form what we say is the partial negative charge, and this will form a partial positive. Partial negative or partial positive, they are not actually positive or negative. So this is not like ionic bond where this should have negative charge and another atom should have positive charge. These are just partial. And why are they partial? Because it is not actually that the electrons, they are transferred from hydrogen to chlorine. They are shared, but chlorine attracts more electrons. Ina nguvu kubwa ya kuvuta electron kuja kwake. Kwa hiyo sasa hapa kwenye kuandika tunaweza kuandika kwamba hizi electrons zinakuwa zimevutwa sana. Remember in the non-polar I told you that when we are drawing this, we can say that these electrons they can be put at the center. But here they are put near to the chlorine atom, indicating that the ability of chlorine to attract electrons is greater than the ability of hydrogen. So here, the effect of pulling electrons towards chlorine and forming the slightly positive, partial negative and a partial positive charge will result to something called a dipole moment. So here, we can draw it as this arrow, then we are directing this way. So you draw this and then you draw this arrow. This is what indicates a dipole moment. So this is a dipole. So what is dipole? Simply, polar covalent bond has a dipole. Dipole, which is a separation between positive and negative charge. So the dipole can be illustrated by using an arrow with an arrowhead pointing the more negative atom. So dipole simply means dipole is the separation between positive and negative charge. But dipole moment indicating the force of attraction. The force of attraction of the electron towards the more electronegative atom. And it is drawn or it is indicated by this arrow. So that's an arrow for indication of the dipole moment. So now what are the conditions for the polar covalent bond to be formed? These questions are asked directly in the exams, so you must understand them. What are the conditions for the polar covalent bonds to be formed? So the first condition for the polar covalent bonds to be formed is the difference in the electronegativity of the atoms. As you can see here, chlorine has the more electronegativity compared to hydrogen. Other examples can include hydrogen fluoride and different elements and compounds which we shall see. So the first condition is that the elements, combining elements, should have different electronegativity. And the second condition, the presence of dipole moment. So during the formation of the polar covalent bond, difference in electronegativity will cause the formation of the partial negative and partial positive charge. And then this later will cause the formation of a dipole moment. So now, let's go directly to look on the polar molecules or polar compounds. So, polar molecules. And sometimes you can be asked a question to say if the molecule, they are polar or they are non-polar. And if they are polar, you can ask the question to draw what they are dipole moment. And also, as we shall go to discuss later about other types of the covalent bonds, you shall go to see the importance of this polar negative and then polar positive charge in the formation of the covalent bonds, as we shall go to discuss later furthermore. So polar molecules or polar compound, polar molecules or compound is the compound that is either ionic or that has a permanent dipole moment. So all ionic compounds, they are polar. And all polar molecules, they have ability to dissolve in water to give positive and negative charges. However, in these covalent bonds, they can sometimes not dissolve, they can be dissolved not completely, but they dissolve in water. And that's why they are called polar. As we know the principle that polar dissolve polar. So water is the polar molecule. And it can dissolve only polar molecules. So these compounds which have the permanent dipole moment, they have the ability to dissolve in water. That's why, for example, this hydrogen chloride can exist as the gas, as hydrogen chloride gas, or can exist as an acid, as HCl. And in all of these conditions, it have the ability to dissociate into hydrogen and chlorine ions. So ability of the hydrogen chloride to dissociate into the hydrogen and the chloride ions, indicating that hydrogen chloride is the polar molecules. Even if it is covalent, but it has the permanent dipole moment, that's why it dissolves in water. So this is different from what we understood in our O-level studies, that all of the covalent bonds, they don't dissolve in water. That's not true. The non-polar covalent bonds, they don't dissolve in water. But the polar covalent bonds, they have ability to dissolve in water since they have the permanent dipole moment. And that permanent dipole moment will enable them to form the hydrogen bond with water, as we shall go to discuss later about the concept of the hydrogen bonds. So, saying that polar covalent molecules has polar covalent bonds, but some molecules with polar bonds are non-polar. They have polar bonds, but they are non-polar. And here is where the confusion starts, as we shall discuss later. So the molecules which are non-polar, although they have polar bonds, are those in which the bond dipole cancel out each other. Cancellation of the dipole depends on the shape or orientation of the polar bonds. Depends on the shape and the orientation of polar bonds. Now, this is a very important concept to understand. Very important among the concept of general chemistry. Most of teachers, they want to ask, and they like to ask questions here, that why some of the molecules, they have polar bonds, but they don't have the dipole moment, or why some of the molecules, they have polar covalent bonds, but they are non-polar molecules. They are non-polar because the permanent dipole cancel out each other. So saying that, for example, if the molecule has permanent dipole, and those two permanent dipole, one permanent dipole goes this direction, and another permanent dipole goes that direction. Remember, this direction can be regarded as the negative, while this direction can be regarded as the positive. So if the one permanent dipole goes this direction, which is negative, and this goes this direction, which is positive, and if these dipole moment they have equal values, maybe saying this is 2 and this is 2, they can cancel out each other. And the cancellation of this dipole moment is what we call this molecule to become a non-polar molecule. And even if when it is dissolved in water, it can't dissolve in it. So, for example, we have the beryllium fluoride, which can be written this. So, in beryllium fluoride, we can have, say, we can have beryllium here, and then we can have 2 fluorines. One fluorine is here, and another fluorine is here. So, from here, this fluorine is more electronegative than beryllium. So the electrons will be attracted toward this side and will be attracted toward this side. And this here will form the partial positive and then partial positive. The direction of the dipole moment will be this way, and the direction of the dipole moment here will be this way. So the electrons now, they are attracted from the beryllium to the fluoride atom, and here they are attracted from the beryllium to the fluoride atom. But as you see, the direction of the dipole moment here, they can cancel each other. So the cancellation of the dipole moment will lead to an atom, will lead to a molecule to become non-polar, even it have the polar bonds. Another example can be water. And here for this case, we can say that this is because the 2 equal bonds, dipoles, point opposite direction and cancel the effect of each other. And teachers, when they ask you about this question, they can tell you to illustrate that these molecules, they are polar or they are non-polar by drawing the diagram like this. So saying maybe water, if maybe we have water. So most of the students, maybe they could expect water to be like this, maybe oxygen, then hydrogen, to be like this. And then as we know that hydrogen is more electronegative than oxygen, we could expect that hydrogen here could be partial negative, here could be partial positive, partial negative, and partial positive. This is actually what happens. But most of students could know that here the dipole moment, because here we have this dipole moment, and here we have this dipole moment. So what they could expect here is this dipole moment will cancel with this one. But this does not happen. Why does not happen? Now, listen to me. This doesn't happen because the oxygen has what we call the lone pairs. As I told you before, that the group 6 element will have 2 lone pairs. And as we shall discuss later on the theories of bonds, lone pairs, they tend to push the bonds because lone pairs are electrons, and these bonds, they are shared electrons, so they repel each other. So this does not happen in water, and this is not the shape of the water molecule. So how the water molecule exists? So in water molecule, we may have oxygen here, and then we may have oxygen here, hydrogen here, and we have hydrogen here. Why water molecule exists like this? Because the presence of the 2 polar molecules in oxygen, I mean the presence of the 2 lone pairs. Lone pairs can be drawn as the dots like this. These lone pairs, they push the bonds, and then they are coming from their straight position as in the beryllium fluoride into that bent position. This is different from the beryllium because beryllium has no lone pair, as we know that beryllium is the metal, so has no lone pair. However, there, oxygen has lone pairs. So now, due to this position, now the dipole moment will be in direction like this, and another dipole moment will be in the direction like this. And here, the partial positive and the partial negative will be formed as usual. So we will have partial positive and partial negative then partial negative, partial positive. And the formation of these partial positive and partial negative cannot cancel each other. So as a result, you will see that water is the polar molecule. Why is the polar molecule? Because the dipole moment, it has the permanent dipole moment, which cannot cancel each other. And that's because of the presence of the lone pair, which push the bonds and leading them to have the direction like that. And water here have what we call bond angle, which is I don't remember its value. I wanted to ask to write 180. 180 is not the bond angle, maybe 80, but I don't remember its value exactly. However, we shall discuss it later on the concept of the bond angle when we are discussing with the bond properties. So don't worry about that. So in water has a net dipole moment. This is because the two equal bonds dipole point in the same direction due to the presence of the lone pair of the electron of oxygen atom. Hence, the bond dipole do not cancel the effect of each other in the lone pair. And that is the illustration of the water molecule. Now, we may have another molecule such as carbon dioxide. Taking another molecule such as carbon dioxide. Now, in carbon dioxide, what will happen? We shall have the carbon atom in the center, and then double bond oxygen, and then double bond oxygen. But remember, I told you that group 4 elements, they don't have lone pair. So carbon here have no lone pair. If carbon has no lone pair, then what happens next? What will happen is that oxygen is more electronegative atom compared to carbon. So electrons will be attracted towards that direction, and here the electrons will be attracted towards this direction. And as far as the carbon has no lone pair, there is no lone pairs which can cause the bend of these bonds. Then what will happen? I hope if you understood me in the example of the beryllium fluoride, and here you can understand me that here the dipole moment will cancel each other, and the molecule as a result will become non-polar. Will become non-polar even if it have polar bonds because of the cancellation of the dipole moment with each other. Another molecule is sulfur dioxide. So a teacher can bring to you these molecules and can tell you to assess and to say why are they polar or why are they non-polar, and can need these diagrams. So you must understand. Just don't just want to claim, just understand them and it will be easier for you to study. So sulfur dioxide, saying for sulfur dioxide, it will form bonds like this will be sulfur and then double bond oxygen and double bond oxygen. But remember, sulfur is the group 6 element. So being group 6 element, sulfur will have how many lone pairs? 2, as I told you. So here, sulfur will have 2 lone pairs. And as I told you in the case of water that the lone pairs tend to push the bonds. So the structure of the sulfur dioxide molecule will not again be seen this way. And these lone pairs will push the bonds, and these lone pairs will push the bonds. Then what will happen is that sulfur dioxide will exist like this way. So if the sulfur dioxide will exist like this way, here, and the sulfur dioxide will exist like this way. Here the electrons were put to the oxygen, and here partial positive. Here put to the oxygen partial negative, partial positive. So I know both oxygen and sulfur, they are group 6 elements. But why electrons are put to the oxygen and not sulfur? That is because of the concept of the atomic size. Oxygen is the 16th element. So it has atomic number of, it is the 8th element. It has atomic number of 8. So having atomic number of 8 means it has small atomic radius as compared to sulfur. So however, they are from the same group, but oxygen has the higher electronegativity as compared to sulfur. As we shall study later in organic chemistry, and you can understand well these trends of the periodic tables, that how electronegativity varies as we go down the group. As we're moving from the higher element and we are going down the group, the electronegativity decreases. So as the electron is at the top of the group as compared to sulfur, which is at the bottom, as the oxygen is period 2 element and sulfur the period 3 element in the same group 6C, so oxygen will have the higher electronegativity as compared to sulfur. So now here we could expect that we'll have the dipole moment going to this direction and the dipole moment going to this direction. And if we couldn't have the lone pair in the sulfur, means that the dipole moment could cancel each other. But the presence of the lone pair in sulfur lead to the dipole moment not to cancel each other. And as a result here, the electrons will be pulled now towards the oxygen as usual, and here towards oxygen as usual, forming a permanent dipole moment leading to sulfur dioxide molecule being the polar molecule. And we have different molecules depending on these facts. As you shall download the notes in my Telegram group, you shall see these different molecules and the explanation. Why are they polar and why are they non-polar? And as we shall go later, we shall discuss how our teachers asking the questions in this particular part of the topic. But for this time, let I tell you that meet the next lecture, meet the next period when we shall be discussing about the dative or coordinate covalent bond. So this polar covalent bond is the second type of covalent bond. And then in the next lecture, we shall be discussing about the dative covalent bond. Subscribe to the channel, join my Telegram group, comment anything if you don't understand, and then I will consider them for more and more details. Thank you.